Hello, my name is Elster and welcome to Get a Grip Failstacking 1. Prior information. Yes, this is a PowerPoint presentation. I do feel like this topic benefits from more of a lecture style video compared to showing you in-game footage. Uh, Black Desert has a chance-based enhancement system, so a lot of calculation is involved. Not that difficult, but if you struggle with handling chances and percentages, I will go very slow and step by step. So even if you have not had that much contact with those kind of calculations, you can follow along and hopefully understand it a bit deeper. Yes, this video is not for you, of course, if you're a Moose or Ninja main. Don't think I have to explain that one. You're in the group of people saying every click is 50-50 anyways, so it doesn't matter. Or your household has an above average tinfoil consumption, meaning the chances written in Black Desert are not the actual chances anyway, or you're already annoyed at Narugear, then it's probably best you search for a different video. So the content in this miniseries, in the first video, which is this one here, I will introduce you to chance calculation. Important distinction here, we will only look at the averages. So we will not calculate the spread and all that jazz, just the averages. And this is very important. It is not it is the expected value which we will calculate, but not definitive. It's important distinction here. It's averages, and I cannot tell you that enough. Then we will calculate the resource consumption, and in the second part of this video, we will create an Excel sheet for basically everything I'm talking about in the first part for a plus 14 Reblath armor, which was the old way to get fail stacks up to plus 30. The second video will be creating an Excel sheet for calculating failstack systems. I will tell you what that is later, which is what I call a failstack design tool. And the actual useful application for in-game purposes. And one or two utilization examples for this failstack design tool. So let's start with the very basics. Looking at the enhancement window. In the middle of the screen, you do have your total enhancement chance in percent. On the bottom, the three numbers. The first one is your actual real fail stack. The second one is the Valk's Cry. You can artificially enhance your fail stack by up to plus 13. And the lowest of the three numbers is your complete fail stacks, which includes the real fail stack, the Valk's Cry, and your base chance. You can get increase that base chance up to plus 5 by doing quests, but I assume most people have plus 2. The added rate at the bottom is the added rate by the fail stack uh, compared to your baseline. So if you have a base stack of plus 2, the base chance is the added rate at the fail stack 2 for you is 0%. So that's your baseline, which is the wrong one to use for the rest of the calculation. Comparing it to a failed stack where there's nothing in it, you do see the base chance of plus 2 and the added rate of plus 0% I was just talking about. So this 2.4% is not the real base chance. Important distinction. Then let's get to the chance formula. So if you create an Excel sheet, you do not have to write all the numbers by themselves. If you increase the fail stack from plus 2 to plus 3, it's a one fail stack increase, and the chance increases by 0.2%. You can also read that at the bottom here. So if we have 2.4 and we get to 2.6, we can continue that all the way to plus 30 or whatever. But we can also calculate back to one base chance or one fail stack, it's 2.2. And we can go further back to the real base chance of 0 fail stacks with a base chance of 2%. Then we do see the 0.2% is 10% or 1/10 of the 2%. And the fail stack at 0 fail stacks is the base chance. Yeah. So we get the formula. The enhancement chance is the base chance plus the fail stack divided by 10 times the base chance again. It's not that complicated here, so I will not go into too much detail, but the formula is accurate. You can test it. Let's test it for a plus 30 fail stack. We have plus 30. You can just apply that. That's why I've chosen that. Including the base chance, our fail stack is 32. So we have the chance, it's 2%, which is the base chance for plus 14 Revelath. We have the 32, which is the complete fail stack, divided by 10 times the base chance, and it comes out to 8.4%, which is what we have. So the formula is accurate. Important to note, there are soft caps and hard caps when it comes to fail stack calculation, how the percentages increase with increasing fail stack. But you can look those up yourself, and usually they are not relevant, except if you're enhancing accessories, but usually you only start at the soft cap, so the formula is different. But for most real cases, when you're fail stacking or enhancing anything, you do not go over the soft cap anyway, so we just not look at that in detail. But just verify the chances that your calculation is accurate before you actually create a spreadsheet and you sink your money in the game. Quick the terminology I use for the fail stack. A click is a single click on the button enhance in the game, just so we're on the same page. A fail stack is a sequence of multiple clicks, and usually you have a goal fail stack where you stop and you basically save the fail stack and use it for the actual enhancement you want to have. A fail stack system is a combination of multiple fail stacks. This will be relevant in the second video, not in the first one. So, chance. When you want to create a fail stack, as I just said, you have multiple clicks you do. You have the zero, for example here, the zero fail stack. You have a 2% chance of enhancing the item to plus 15, meaning you do have a 98% chance to fail the enhancement, which will generate the one fail stack you want. The formula is here, fail chance equals 100% minus the chance of the successfully enhancing the item. Important to note, every click is a single point of failure, meaning if I fail any of these clicks, I will have to start over from the beginning, which makes it easy to calculate. So to get the fail stack I want, here is the fail stack is 6, because I click on I have 0 stacks, I fail this one, I get 1, I fail this click, I get 2, I fail this click, I get 3, and so on. So if I fail this click, I get 6 fail stacks. And to get the fail stack, all clicks have to fail. Let's switch the perspective to the fail stack perspective, meaning instead of taking the fail stack where we start, which is 0, we translate that to which fail stack will we get if we successfully fail the enhancement. So we do have a 98% chance to get one fail stack. We have afterwards, if we reach this point, we have a 97.8% chance to reach 2 fail stacks. For example, if we're already at 4 fail stacks, we have a 97.2% chance to reach 5 fail stacks. Okay, it's not that difficult, but this switch in perspective will have a few advantages later in calculation. So let's calculate the total chance of creating the whole fail stack. Let's use an example here. We click the first click 1000 times. It does have a 98% chance to give us the fail stack, meaning on average, and this is important, it's average, okay? So if your sample size is too small, you can deviate a lot. If your sample size is big enough, you will approach this percentage number. Not necessarily the fail amount exact, but the total chance will be very close. For example, if you do 10,000 clicks, you will be closer. General rule of thumb, the smaller the chance, the bigger your spread for in-game application. So if you use a 5% chance, it can be rather spread. If you have a 70% chance or 50% chance, you more or less will be somewhere in the range faster. So we calculate the chance, which is just the fail amount divided by the amount of first clicks, because we want the total chance. We started with 1,000 clicks into this whole journey, and 980 clicks successfully got through the first click. So we start with 980 for the second click. We do have a certain percentage. We can just multiply these numbers and we get the 958.4. So we have the total chance. And next click, we start again with the prior fail amount and we get the amount afterwards. We can continue that for the rest of the clicks. So the total chance at the end is 85.9%. We can also just multiply all the chances with each other to get the total amount, because every click is a single point failure. So to successfully get the final fail stack, all of these have to fail in a row. And you can verify that by using the simple example I provided here. So the total chance for the first fail stack is, of course, 98%, right? It's the first click, 98%. Then the second click, to give you the explanation behind why you can just multiply it, we only reach this point 98% of the time. And then we have a 97.8% chance to get the two fail stack. So we multiply these numbers and we come out to 95.84%. Do it again for the next one. We only have a chance of 95.84% to even reach this point. Then we have the chance of 97.6 and we get 93.54%. So we multiply the chance of our click with the prior total chance, which is just the product of all clicks up to this point. So we have the total chance. What can we do with that now? We can calculate the amount of reruns we have to do. Reruns is what I call how often do we have to start on the first click to successfully get the final fail stack we want. The final fail stack here being 6, but the reruns, of course, being calculated for each click. So we do have to start, the formula is reruns is just 1 divided by the total fail chance. Fail chance being this total chance here we just calculated, because we're in the fail stack perspective, right? Let me just write you why this formula is correct. I'm not sure if that is clear. You have a number of attempts, okay? Let's just call it A for attempts. You multiply that by the chance, or the total chance, but just the chance. This is good enough for here. So it's a percentage. For example, 98%. And we do get a number out of it being yes, 0.98. But what we do want to have, we do not want to have 1 here, this number, but we want to have 1, right? So we do need a number A times the percentage being equal to 1. And to get that, just we have to divide by the percentage. Yeah, it's the weird the way I wrote that is weird. Let me restart that real quick. This is, I guess, slightly confusing. Let's start at a different point. Am I still black? Yes. So we have an attempt times our percentage, and we want that to have 1. That is the goal. We want to norm everything to we fail this click once. It just gives us an advantage in calculation. So it's just an equation, and we can divide that by 98%. So we get number of attempts to reach that. This one here is just 1 divided by 98%. I hope I did not confuse you too much here, but yeah, that's just where this formula comes from. You can try it out yourself in case you're wondering. So back to the main topic. The first reruns, just with the formula, is we have to start 1.02 times the first click to get this fail stack once, so slightly above 1, which makes sense because we do not get it every time. We can just continue calculating it for the rest. So we to reach the fail stack of 6 once, we have to start from the very beginning, on average 0.164 times. And this is important. It's average. You can, of course, start it once and get it. You can start it 7 times in a row and not get it if you're unlucky. But on average, if you create, for example, 100 or 1000 or 10,000 of these 6 fail stacks, you will on average have to start from the beginning 1.164 times if your base chance is 0 for this example. And that's the important part. It's average. Okay? Important to understand. So one more thing, and this is not relevant for the example of plus 14 Reblath or plus 14, but it's the most important information to actually apply the failstack designer in the next video. And this is how often do I succeed in my enhancement. This will be relevant to balance the duo, try, tet, reblath you get by actually useful failstacking examples. So we do have our fail chance, our total fail chance. We already have that, and we have the reruns. So how often do we get a plus 15 reblath? For the first click, and this is important, this is just the click itself. I click it once. I have a 2% chance of successfully enhancing plus 15. So just 1 multiplied by 2% is 0.02. But for the fail stack we already discussed, I will have to start over from the very beginning 1.164 times. So by the end, when I have created the 6 fail stack, on average, I will have created at this position of the first click 0.023 plus 15 reblath. So slightly more than if I just count the click itself. Then for the second click, it's just the 2.2%, so basically the same calculation as the first one. But we have an additional piece. We have the 0.022 times the 1.164, but we also have to multiply by the prior total chance, being 98% for this click. Reason being, we only can attempt the second click 98% of the time. I hope this is clear why, but this is very, 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 very important to understand that. Of course, understanding, in case I did not mention it yet, is important. If you use the tool, you have to modify it, of course, and probably you have to transfer it to your own problems. So to be able to correctly transform it, it's very beneficial if you actually understand why the formulas are the way they are. So we just look at the rest of them. For example, the 6 click here. We generate 0.03 each time we click it. So we multiply this number by the prior total chance being around about 88.5%, and the number of reruns being 1.164. The reruns, by the way, for this example is close to 1, yes, but for actual applications it's usually between 2, and for the stacks upwards of 100 you get reruns between 20 and 30 sometimes. So this multiplication by reruns is very relevant. Yes, and you can just wait, what did I do here? Interesting. You can just sum up the Reblath, and this is the total amount of expected plus 15 Reblath you do get when you successfully create the failstack of 6 once. So every failstack of 6 you create on average 0.164 plus 15 Reblath. It's just the sum. So let's talk about resource consumption, which is probably what you're actually interested in. Meaning, how many blackstones do I have to use? Or, for example, if you want to optimize your Tuvala because you want to be faster in season, you can optimize to these, how they called, something time, something blackstone, to need less of those. Or, for example, if you enhance anything else, you can optimize for silver, which is probably what you want. So we look at our number of clicks we had prior on a few slides back, and we just sum up the amount of clicks. So to reach the 6th click, and we start 1000 with the first click, it's 5670.6 clicks in total to reach this point. Every click requires 1 blackstone. So we divide the result. We have 859 successful stacks, and we just divide the amount of used blackstones by this final result, meaning 5670.6 divided by 859. So that's an average of about 6.6 blackstones per stack. It's not relevant, but it's an easy example you can follow along, and you can actually try this out in game if you do not believe me. So how do you calculate it step by step? Because you don't always want to use this this 1000 click example. The formula is the cost of my click plus all prior cost, because the prior cost is the cost I had to invest to reach this point where I'm at, and divided by the fail chance for the click. So for the first one, it's 1 blackstone plus 0. I had 0 prior investment, divided by the 98%. So it on average takes 1.02 blackstones. The second one, I have to invest the 1 Blackstone for the click itself, plus I have to invest all prior cost, meaning 1.02 Blackstones for the first click, divided by 97.8%, and it comes out to 2.07 Blackstones on average. You can just do it for the rest, and let's look at the last one. 1 Blackstone for the click itself, plus 5.4 Blackstones for all the prior cost to reach this point and be able to click this click, meaning 6.6 Blackstones on average, which is the same we calculated when looking at the example. What we will do in the Excel calculation in a second, we will compare the calculated values of resource consumption, Blackstones in particular, and compare them to the cost of applying Failstacks in game. And I will show you there that just applying them is cheaper and faster, of course. So this old stacking method is outdated. In case you do not know where you get that, you have your enhancement window, you have your additional enhancement chance, and if you're at +0, you can click the plus. Then you can select your Blackstones, either weapon or armor, doesn't matter, but generally armor are cheaper. And you can apply a fail stack for a certain cost. If you apply a 30 fail stack with a 2 base chance, the resulting fail stack will be 32, right? Self-explanatory, but yeah. So, how does silver work? It's basically the same, but we exchange what we did prior with a cost per click, and the prior cost just with the silver cost. And we add in the repair cost, because while it's not relevant for Reblath, it is relevant if you're looking, for example, you want to use the tool for calculating cost on enhancing boss gear or Black Star or whatever. So you need to add in the repair cost. Now, where do we add that? We have our prior formula, which is just the same. Instead of Blackstone, we work with silver. I usually use millions because, yeah, everything costs millions. And afterwards, you add the repair cost. Why do you add them afterwards? Because the cost we're calculating is to get the fail stack once, meaning we click so often that we successfully fail once, because failing generates the fail stack and we want that. And whenever we fail, we have to repair. We get the durability loss, meaning we do fail exactly once per cost calculation, so we can just add it. So do I have it here? Yes. For the first one, it's the 0.2 million if we calculate the Blackstone cost at 120,000 a piece, divided by the chance, plus the repair cost for Reblath plus 14. It's this weird number that's just the 12,900 the Reblath shoe costs, and you lose 5 durability a click, so that's half of that. So you get your cost per click. You can do that for all the others as well. For the second, for example, you have your Blackstone price again, plus all prior costs, including the repair cost for the first click, and divided by the chance again, and you add the repair cost. You get your total cost up to this click. Oh, yeah, this is wrong. This is the value of the last click. It should be 0.26, of course. Let me fix that. I did not see that. True. So this is wrong. It's 0.26 million. That's better. And what is missing for this specific example is the cost to downgrade the plus 15 Reblath back to plus 14. You can do that, I believe, at Tecton already. In Velia, for example, the how do you call them again? Smith. It costs 100,000 per piece, so 0.1 million. And we did already calculate the amount of plus 15 Reblath we can expect per successfully reaching the failstack of 6. So we just multiply them. We multiply the 0.1 times the 0.1 times the 0.164, and we add that and on top of the value we calculated. It might not look like that makes a lot of sense because we had 0.1 1 and we get 0.2 difference here, but that's just because I generated these numbers with Excel, so they're surrounding. Yeah, that is just rounded somewhere in here. So this number is slightly higher probably, and this number is somewhere around the area of 0.846 or something. So it's just rounding error here. So see you in Excel in a second. On to Excel. I do have a empty sheet here and the blueprint on the second monitor just to help me along. I will again go rather slow, so if you do not have that much contact with Excel yet, you can still follow along. I am using the German version, as you can hear by my accent, I'm German. But you can, if there's commands, and there shouldn't really be commands on this first Excel sheet, you can just Google the English version. So let's generate the example. We do have a fail stack, we do have a chance, whoops, remove the plus, and we do have the fail chance. So we just write 0 and 1, for example, mark them, and we can drag them down to get the 32. Because in this example, I will use the base chance of 2. I assume most people are there, so let's just use that. For at 0% fail stacks, we have a 2% chance. We already discussed that. And the formula for the rest of them is we have the base chance. So we select, we type an equal symbol. We select the cell where the base chance is written. We press F4, so we add the dollar symbols before the C and before the 4, just to fix them. We have the base chance, then we do add 10% per fail stack on top of it. So we select the fail stack we have here, it's in this cell. We divide that by 10 and multiply it again with the base chance, and again F4 because the base chance is always written in the same cell. Now we can just select the cell and again drag it all down, and it just fixes the formula. And as you can see, because we put the dollar signs here, this cell is fixed and this cell moves with us, just making it very easy to calculate the chances we have. So let me move that up a bit so we have a bit more space. So interesting for us is of course the fail chance. So it's just 1 being 100% minus the chance, and drag it all down again. We have our fail chances. So we can very quick calculate the total chance. This let's first switch to the fail stack perspective. We can just mark all of them and move them up once. Now we're at the point where the first click, I do have a 98% chance to get the one fail stack. I do have a 97.8% chance to get the fail stack of 2. Okay, so we just move them up, and the formulas switch accordingly, of course. If you look at that, it takes the prior fail stack we had, because to reach the 10, we have the fail stack of 9. We click, and there we do have the chance to reach the 10. So it's, yeah, you will get used to it, and it's beneficial because now we can just select these and drag them down however far we want, and do not have the fail stack written in the next row. So it's quite easy that way. These clicks, however, we can already ignore because we said we do have a base chance of 2, so we already are at the fail stack of 2, right? Let's just mark it. That's where we start, so we don't have to click anything to reach that point. Meaning, we can calculate the total chance. We do have a 100% chance to reach the fail stack of 2 because that's where we start. That's our base chance we selected. You can, of course, switch it accordingly if you have 3 or 1 or 0, for example. Doesn't matter in the calculation. It just switches the numbers of it. So if you want to have your example here, you can, of course, switch it accordingly. So total chance, as we said before, our chance of the click multiplied by the prior total chance and drag it all down. That's the total chances. Then let's just calculate the reruns we need, meaning 1 divided by the total chance up to this click. Drag it all down. Get us a few less numbers. So if you have a base chance of 2 to reach the fail stack of 32, you need to start from the very beginning on average 5.15 times, which is significantly higher than what we calculated before at 1.16, I believe. Yeah, by the way, these chances here are of course different from the presentation because we start at the fail stack of 2 now compared to the 0 from before. So let's look at cost in Blackstones. For the first one, it's of course 1 because you have to invest 1 fail stack to be able to click, and we divide that by the fail chance of the click, not the total chance. So we get a certain number. For the next one, you have to write it in how do you call this in English? It's Klammern in German. It's Shift 8 and Shift 9. I'm sorry, I'm missing the word right now. So we add 1 Blackstone, which is our investment for the very click, plus we add the total cost from before, so to reach this point, which is the prior cost of the click before. And we divide that by the fail chance of the click. And we can drag that down, check the last one for accuracy. So we have 1 Blackstone plus the prior total cost divided by the chance. So that's accurate. Slightly less numbers because they're not interesting. So let's compare them to if you just apply the fail stacks. For the plus 30, we do apply, if we apply the 30, base chance of 2, we reach 32. So these numbers here are relevant for us. And yes, I know I can mark multiple rows simultaneously, but who cares, right? And if we type in the numbers, just you can check them in game, or I had them up in the PowerPoint presentation near the end, so you can just cross-check them if you want. And now we already do see a difference. If we just apply the stack, we need less than if we click it manually. And relevant probably are the last 3, and it's a difference of 2 fail stacks, 3 Blackstones, 2 Blackstones, 3 Blackstones, and even 6.5 Blackstones. Not even including the time necessary to sit there and click on a plus 14 Rebloth. And you cannot store them as nicely as you can store Blackstones, right? You can store 100,000 Blackstones in your storage somewhere, but you would have to buy the books to generate the Advice of Orcs to store the Failstacks the same way. And it's more expensive. So let's do a different look and look at the silver cost. That's probably interesting. Yeah, for the most of you, that's probably what you will use your own tools. So we have a Blackstone cost, we have repair cost, and we have downgrade cost. Blackstone cost, let's set it at 120,000. By the way, because of course I'm using the German version. In the English version, it would be 97.60%. And it's just a comma in the German version, so you can change that accordingly, of course. 6,450 and 100,000 for the downgrade. Because we always work in millions, we divide all of them by millions and we get the value in millions. The first click is basically the same as with the Blackstone cost. It's just we have the cost for Blackstones in millions. Again, press F4 to lock it because the price, the cell where the price is always the same. So we can just fix it and we can divide that by the fail chance. That's the value in millions. For the second one, we do again have the value of the Blackstone itself. So again F4 plus all the prior cost, and we divide that by the fail chance of the click. Plus we add in the repair cost because, as mentioned before, by successfully generating the fail stack once, we have failed once. So it's just you have to repair once. Making sense, right? So we have the total cost from the Blackstone and repair perspective. What is missing here, of course, as mentioned prior, is the downgrade. You have to pay money to downgrade it. It's not. I do understand that it's not relevant directly for the real failstacking process where you use pry, duo, try, and tet Rebloth shoes. But this formula itself is necessary to be able to balance it. The number of duos, tries, pries you use and you create to get a balance there. So just the failstacking process is way less annoying and less costly also, but that's a different thing. So let's look at how many Rebloth we create per click. We do click, we do produce 1 times the chance that it happens per click, which is, yeah, makes sense, right? There's nothing difficult there. So if we click it once, you get a certain number of Rebloth on average out of it. Not really interesting. What we have already discussed before, you have to multiply it by what is the chance that I do reach this point. So we do multiply it by the prior chance. I hope you can see that if I'm here, the prior chance is 100%. If I'm, for example, here, the prior chance is 1 row above. So we can just drag that all down, and it should be, if we go there, 1 above, yes. And let's get a few less numbers because that's stupid, right? this here is one run. So we start from the beginning once and go through all the way. On average, we will have created at these positions, right? This is not the total amount. This, for example, is specifically at this click, and we can sum that up. In English, the thing you have to type here is just sum. In German, it's Summe. So on average, per run, I start from the beginning, I will have created on average 0.8 plus 15 Reblath, which is not insignificant anymore. And for the plus 30 fail stack, because we just want to look at the last one, right? We have to multiply each of those steps by the maximum of the amount of reruns we had. So we just select the whole, is it row? Man, I'm missing my English words today, I'm sorry. But just click on the F. So we do that for all of them, and it stays the same. It takes the maximum value here. And we move that over, so it's still the sum, but for the final row. So, per successfully creating the fail stack of the plus 30 fail stack, sorry. Once we will have created on average 4.15 plus 15 Reblath, which we have to downgrade, meaning to our cost we calculated prior, we do have to add the amount of Reblath we created times the downgrade cost. So I did the weird thing there. Ah yeah, plus, sorry. So it is not insignificant anymore. It's 400,000 difference. But yeah, honestly, this here is just a gimmick to show you how you calculate how many. For example, if we click on pry, you can use this to calculate how many duos or tries you create, which is the relevant part. But for now, this works. So we do have a price added to it. But let's compare it again. How much do the applied fail stacks cost? So we just multiply the amount of blackstones needed times the blackstone price. Again, press F4 to just lock the file, the cell, and we add them here. So you have determined it's more expensive, but you can now determine how much is it more expensive. By the way, you cannot just add the the value we calculated here for the downgrade cost, because all these values change if the number of runs changes. So if you only go up to 22, you have a different amount of reruns. You only have 2.4, so all these values change. And of course, you only sum it up to about, where is it here? Okay, so you cannot transfer that, but even then it's more expensive, of course, because you need more blackstones. But it's, yeah, so silver is interesting to look at, especially because this one includes the repair cost. So yeah, that's it for the first video of this mini series. If you have questions or problems with certain topics I did not explain in too much detail, feel free to write them in the comments. I will answer them. And yeah, see you in the next part. Probably next week. I don't know when I find time. Adieu.